Now, this is something that's a little more complex, so I'll go through it a little bit more carefully. So if you look on the right, this is where Swanson maps perfectly onto Piaget. And I put the Swanson paper in as a optional reading, but if you're interested in the sorts of things that we're covering in this class, that's a great paper to hack your way through, even though it's very hard, because you learn a lot about the underlying biology of some of these more complex clinical and developmental theories that we've covered. So basically, what Swanson is pointing out is that at the lowest level, at the highest resolution level of your central nervous system, you have motor output circuits that are enabling you to move, and those are communicating in large part with your spine, but also with lower parts of your brainstem. So those are fundamental movements of the sorts that Piaget would call reflexive. And then the locomotor pattern generator, I think the best way to think about this from an analogical perspective, and actually Alexander Luria used this analogy. He called behavioral patterns kinetic melodies. It's a lovely phrase, because you know how obviously a song is made out of notes, and then the notes combine into phrases, and the phrases combine, say, into passages, and then, well, even more interestingly then, if it's an orchestral piece of music, multiple instruments are playing at the same time, so it sort of extends right into the social domain. But your actions are sort of like that. They're made out of micro routines, and then those are chained together, and those are chained together in higher order abstractions and so on, all the way up to the cortex. And so Swanson points out that the motor system has three sets of inputs. So the cognitive system, that's sort of way up, that's sort of level of abstraction that's way up in the brain. So the cognitive system is where, you know, you might do a voluntary action. So you look at something, you say, well, I'm going to pick up this piece of paper. And so that's top-down cortical control. And then the state system input to the motor system, the state system is your body monitoring what's going on inside of itself. And the autonomic nervous system is part of the motor output system, and so the state monitoring system takes a careful look, and the hypothalamus does a fair bit of this, takes a careful look at what's going on inside you, and then activates different parts of your digestive and, you know, the gut system fundamentally that you have no conscious control over. And then obviously there's sensory system inputs too. So those are the three main inputs into the motor system, and that acts on the environment. And then the motor system has this hierarchical nature that's built from the spine upwards. And so you can think of like the brain as a collection of ever-expanding control systems that allow you to learn and undertake ever more complex motor schemes of action. You know, and one of the things that people think about human beings is that we're very good at thinking, right? But we're not just good at thinking. Like we're crazily adaptable in terms of our motor output. I mean, if you watch the Olympics, you know, and you see human beings can do things that no other animal could even think of doing. I mean, we're completely crazy when it comes to the sorts of things we can do with our body. Like, we're good on ice, we're good in the water, we can ski, people are really good at jumping, they can climb across buildings. Like, people who train themselves can climb like mad. I mean, human beings are unbelievably variable in terms of their motor output. So that's another part of our intelligence that's not just abstract. And so, in part, that's because we have this very well-developed cortical area that enables us to chain ever more complex patterns of behavior together, and also to develop patterns of behavior that are sort of outside instinctual specification. So you imagine with an animal that has a less complex brain, a lot of its behavior is going to be limited to those quasi-instinctual patterns of behavior that are devoted directly towards the solution of basic biological problems. But, you know, we can kind of solve those without too much effort, and then we have all this spare motor capacity left over, and people do the weirdest things with it. You know, and really remarkable, absolutely remarkable things. So that's pretty cool. We're pretty cool that way. We don't get enough credit for it, I don't think, because human beings, if you think about a human being as an animal, which, you know, people are kind of loath to do, we are definitely the most interesting animal. I mean, if you saw like a pygmy hippopotamus skateboarding, you'd think that was pretty remarkable, you know, but people, they do those sorts of things all the time, and, you know, we just take it as a matter of course.